Hi, so we're going to do the naming of ionic and molecular formulas here. So first we have these pairs of ions that we need to predict the chemical formulas and names. So we have copper 1, that's Cu with a plus. So we know that they have to be neutral. So we have an S2 minus. So in order for there to be two minuses, we need to have two pluses. So Cu plus, that gives us Cu2 and then S. This is copper 1 sulfide. And it's copper 1 because each one of them has just a +1 charge, right? +1. If there's no charge, that's listed, it's just 1. Okay, so now we have iron and oxygen. So we have Fe, and each one of these is +3. And we have O with a 2 minus. So this is a little bit difficult. So if we add another O with a 2 minus, we only have 4 minuses and we have 3 pluses. Let's add another Fe with a 3 plus. Now we have 6 pluses and only 4 minuses, but if we add another 2 minuses, now we have 6 minuses and 6 pluses. So we say that we have Fe2, because there are 2 of them, O3, because there are 3 of these. And this is iron 3, and it's iron 3 because it has a 3 plus charge. Oxide, because oxygen is just oxide. Okay, so calcium, and we have this. This comes off the polyatomic ion chart. It's called carbonate. And they both have a +2 and a -2 charge, so they go together 1 to 1. There's no extra atoms needed here. So we have CaCO3. That's it. Calcium is the name of the cation, and carbonate, CAR, carbonate, is the name of the anion. All right, we have magnesium and this hydroxide thing, but we have a magnesium +2, and we have OH minus, and then we need another OH minus in order to get 2 minuses there, because we have to equal out the charge. So we have Mg, and now we have to put this in parentheses because we have 2 of them, and the 2 has to apply to both the O and the H. So this is magnesium hydroxide. And how do you figure out the hydroxide? You get it right off the polyatomic ion chart. It comes right off of there. Now, this is a complicated one. We have NH4 and SO4, but they're both on the polyatomic ion chart. So we have NH4, and it's a +1, so we need 2 of these to equal this -2 here, SO4. So the name of this is ammonium sulfate. And both of those come off the polyatomic ion chart. It's just the name of the cation plus the name of the anion. All right, name the following compounds. Let's see if we can move this up a little bit. Okay. Name the following compounds. First, we have to decide whether these are molecular, covalently bonded, or ionic. So this one is ionic. It's a metal plus a nonmetal. Whenever there's a metal plus a nonmetal. And lithium only forms 1 charge, so it's lithium oxide. All right, now we have iron here, and iron forms more than 1 charge. So we have to say iron, and we have to figure out what the charge is. This one happens to be +3, and this one happens to be -2, and we can tell because these just get switched. So this is iron 3, and this was carbonate. Remember, we did carbonate up above. Carbonate comes directly off the polyatomic ion chart. Nickel forms more than 1 charge. It's a transition metal. So we have nickel, and it's 2 because the charge on that is +2. And cyanide comes directly off the polyatomic ion chart. Calcium only forms 1 charge, and carbonate comes off the polyatomic ion chart. So we have calcium carbonate. Now, silver. Silver is a transition metal, but it only forms one charge generally. So you can name it with a Roman numeral. I wouldn't kill you for that, but it doesn't need one really. So we say this is silver. And if you look at the polyatomic ion chart, SO3 is sulfite, silver sulfite. Notice it's not sulfate. Sulfate is SO4. SF6. Now, this is not a metal with a nonmetal or a metal with a polyatomic ion like we've been doing. This is all molecular. These are all nonmetals. So we have to name this with the molecular naming. So we have sulfur, hexafluoride. All right, N2O, again, all nonmetals. This is dinitrogen monoxide. Keep in mind that if the first element is only one of them, we don't put the mono in front of it, but whenever the second element is, we do. Now, HF, whenever we have the cation as H, we have to remember that it's an acid. So this is going to be hydrofluoric acid. All right, let me move this thing up because I'm running out of room. XeBr4. This is all nonmetals again. Okay, so we have to use those nonmetal rules. Xenon, tetrabromide. All right, and triphosphorus. Pentoxide. No, decoxide, sorry. Pent is only 5. Dec is 10. Decoxide. I don't know what I was thinking there. Okay. Now, give chemical formulas for each one of these. Let me move this up a little bit. Ammonium sulfate. So we need to remember the ammonium polyatomic ion, that's NH4. And it has a charge of +1. And we know that our sulfate has a charge of -2. So we need 2 of these guys. NH4, 2SO4. I'm going to do this one over here so I have more room. Sodium is a +1. Acetate is C2H3O2. And it only has a -1. So they're just 1 to 1, just like that. Magnesium chlorite. Okay, so we have Mg, which is a 2+. Chlorite is ClO2, but these are only -1, so we need 2 of these in order to get the +2 balanced out. Copper 1 chloride, so we know it's Cu, and that has a +1, and chloride is just Cl, and that has a -1, so they just go together like that. Cobalt hydroxide, we have cobalt 3, and hydroxide is only a -1, so we need 3 of these hydroxides to take that charge away. All right, chlorous acid. Now remember the 8-ic-us. So this has to be from the chlorite ion. So we know that H is our cation, and ClO2 is the chlorite ion. So they're 1 to 1 here, +1, -1. So it just goes like that. All right, nitrogen monoxide. So we do a nitrogen, and we just have 1 oxygen, so it's monoxide. Phosphorus trichloride, so PCl3. Potassium permanganate, KMnO4. MnO4 just has a -1, and potassium has a +1. Lithium sulfide is Li. And then we have 2 because they're +1 each, and S has a -2. Li2S. All right. So hopefully that helps.